Hello friends, welcome to Independent Learning. My name is Raj Shah and in this video we are continuing with the chapter Quadrilateral. Okay, in the previous video we saw proofs on all the theorems based on parallelogram. We also saw proofs on these four statements. Okay, so in this video we are continuing with the chapter and we are going to, based on these theorems, we are going to solve questions. Okay, we'll take some questions and we'll try to solve it. Okay, based on these theorems itself, which says, let's see what the theorems are. If pairs of opposite sides of a parallelogram are congruent, then that quadrilateral is a parallelogram. So if you want to prove that a quadrilateral is a parallelogram, then we have to show that their opposite sides are congruent. Okay, that means if you want to prove that this is a parallelogram, that means we have to prove these two sides, okay, opposite sides are congruent. Correct? That's what the first theorem says. Then the second one says, if both the pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. That means if you want to prove ABCD a parallelogram, we should be able to prove that A and C are congruent and B and D, they are also congruent. That's what this says, which is opposite angles, pairs of opposite angles should be congruent. If it is congruent, then the given quadrilateral is a parallelogram. Okay, so I hope you understood the first, the second. Now the third, which says if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So if you draw diagonals on this, let's say this is A, B, C, D and this is O. So diagonals bisecting, if the diagonals bisect each other, then it is a parallelogram. That means if AO and CO, correct? You know what is diagonal? I mean, what is the meaning of bisecting? So BD is dividing AC into equal parts, which is AO and CO, they are equal. Same way, BO is congruent to DO. So that's what bisecting means. So if this is happening, then this is a parallelogram. Okay, that's what the theorem says. So here actually these theorems which we are discussing, okay, these theorems, they are all what? Test of parallelogram. So any quadrilateral, if you want to prove that it is a parallelogram, then any of these can be used. So this is actually, the video is based on questions on test of parallelogram. Okay, so the last one, which says a quadrilateral is a parallelogram if a pair of its opposite sides is parallel and congruent. So if you consider just this quadrilateral ABCD, then if you want to prove that this should be a parallelogram, then okay, I'm sorry, what does it say? A quadrilateral is a parallelogram. So when will this be a this quadrilateral be a parallelogram? When opposite sides, see, if a pair, so at least any one pair, not at least, sorry, any one pair, like if I say AD is congruent to BC and AD is parallel to BC. So any one pair of opposite side is congruent and parallel both. See, if a pair, a means single pair, of its opposite sides is parallel and congruent. So either this or AB parallel to CD and AB congruent to CD. So either this or this, any one. So any one pair of opposite side, okay, if it is parallel as well as congruent, then it is a parallelogram. Okay, so I hope you have understood test of parallelogram, or you can say test on parallelogram. Okay, so these are the theorems. If you want to prove that a given quadrilateral is a parallelogram, we can use any of these. So now based on these, we'll be taking questions. Okay, so let's see them. So the first question, which is written here, we have to prove that every rhombus is a parallelogram. So if this is the given rhombus ABCD. So we'll just write what is given. Quadrilateral ABCD is a rhombus. Okay, what is to be proved? We have to prove that ABCD is a parallelogram, correct? So this is given as rhombus and we have to prove that every rhombus is a parallelogram. That means this rhombus should be parallelogram. Okay, now you already know what is a rhombus. Okay, rhombus is a quadrilateral which has all four sides equal. Okay, so here in the proof we can say, since ABCD is a rhombus, that means we can say AB is equal to BC equal to CD equal to AD. Because ABCD is a rhombus, and if a quadrilateral is a rhombus, then all sides are congruent. Okay, so this is what we write, because ABCD is a rhombus. So we can say the reason: all sides of a rhombus are congruent. Okay, now consider AB and CD. AB and CD, they will also be congruent, yes or no? Now BC and AD, consider. So if you consider these two, again AB is congruent to CD, yes or no? Actually AB is congruent to all three, all the other three. But let's consider AB congruent to CD and BC congruent to AD. So here if you see opposite sides, right? Opposite sides are congruent. Therefore, we can say quadrilateral ABCD is a parallelogram, because all sides are equal, and also you can say that opposite sides are also equal, yes or no? So we just consider these two and then these two together, and then from this we can understand that opposite sides are congruent. Therefore from this, if pairs of opposite sides are congruent, then it is a parallelogram. So we can write the reason here: opposite sides are congruent, that's why this is a parallelogram. Okay, so I hope you have understood this. Now we'll take some more questions. So let's take some more questions. So here this says, the second question, that ABCD is a parallelogram, okay, which is already given. P and Q are the midpoints, okay, of AB and CD, that is given to us, and we have to prove that APCQ, okay, APCQ is a parallelogram. Okay, so how do we prove this? We can prove it by, okay, let's see what is given to us. When we start the proof, now AB and CD, they are parallel, yes or no? So now you already know how to prove that a quadrilateral like APCQ, how do we prove that it is a parallelogram? Okay, how do we prove it? By proving that opposite angles are congruent, or by proving opposite sides are congruent, or by saying diagonals. So here diagonals will not be involved. Okay, so leaving that, the fourth one, which says opposite sides, any one pair of opposite side is congruent as well as parallel. Okay, so any three from these three, try to prove any one. Okay, so use any one and you can prove that APCQ is a parallelogram. Okay, so here the easiest one which you can see is AB is parallel to CD. Therefore, can we say this AP and CQ, they will also be parallel? Yes or no? So here, okay, let's write that parallel afterwards. Let's see first AB and CD, they are congruent. Why? Because opposite and sides of a parallelogram is congruent. So we can say the reason: opposite sides of a parallelogram are congruent, correct? Therefore, if these two are congruent, now can we say AB, okay, AB is equal to half of, sorry, AB, why, sorry, AP is equal to half of AB. Why this? Because if you see AP, P is the midpoint, yes or no? So if we write this AB as AP plus PB, yes or no? AP plus PB. Now PB is same as AP because they both are congruent because P is the midpoint. Therefore, this will also become AP equal to AP because reason will be AP is same as PB. Therefore, this will become 2AP. Correct? So, AB is equal to 2AB. Same way, we can show that QC is equal to 2 DC or CD. Correct? Same way like this, we can show like DQ plus QC, okay, is equal to DC. Then instead of DQ you write QC itself, so 2QC is equal to, sorry, so CD is equal to 2QC. Correct? So this is what we get. Now, so we have got these two. Now can we say if these two are equal, okay, AB is congruent to CD, substitute these two values in this, let's see what we get. So we get 2AP is congruent to 2QC, correct? Like this and this is congruent, that's why substitute AB as AP, sorry, 2AP and CD as 2QC. So here 2 is gone, you get AP congruent to QC. So in this quadrilateral APCQ, AP and QC, they are congruent. Now if AB is parallel to CD, yes or no? If this and this, they both are parallel, can we not say that AP is parallel to CQ? Yes or no? Because if this and this, okay, this is parallel to this, okay, or we can say if this line is parallel to this line, can we not say that this will be parallel to this? Yes or no? If I just remove this, right, the upper part and the lower part of the two lines, so we can say that these two are also parallel because they are the same line. Yes or no? So this and this, they will also be parallel because they are the same line of AB and CD. Therefore, this will also be parallel from 1. Correct? Now, we got, let's say this is equation 1, let's say this is 2 and this will be from 2. So, from 1 and 2, we can say quadrilateral APCQ is a parallelogram. Why? Because one pair of opposite side is congruent as well as parallel. So you can write that reason. Okay, a pair of opposite sides is parallel and congruent. Okay, so this is how we prove that a quadrilateral is a parallelogram. Okay, so this is it, this question. Now let's take the another question. So here the third question, which says that what is given here, ABCD is a parallelogram. Okay, ABCD is a parallelogram and we have to prove that PQRS is a rectangle. So inside this, and these are what? AR. So these, whatever these dotted lines, they are all what? The bisectors of angles. Okay, so these are what? the bisectors. That means we can say that this and this are congruent, this is congruent, this, let's represent this as division, these two are congruent, then this and this is congruent. Okay, because all of them, from each and every vertex there is an angle bisector which is going through, and there is a rectangle which is formed because of the angle bisectors from all four vertex. Okay, so we have to prove that PQRS which is formed, we have to prove that it is a rectangle. Okay, so let's see how we can do. Okay, now can we say like ABCD, what is it? It's a parallelogram. So if it is a parallelogram, can we say that interior angles are supplementary like this? This is A and this is D. So can we say angle A plus angle D equal to 180 degree? Yes or no? So this angle plus this angle is equal to 180 degree. Yes or no? Why? Because interior angles. So we can say interior angles test. Now A and D. So now can we say this A, okay, dividing throughout by half. So half of angle A plus half of angle D plus is equal to half of 180. Now why are we doing this? You'll understand why. Okay, so half of angle A. Now this and this, they both are what? Congruent. So if this angle and this angle, they both are congruent, can we say angle, okay, SAB plus angle SAD is equal to angle this. So this angle plus this angle will give us DAB. Yes or no? Which is this angle DAB, or we can simply say angle A. Yes or no? So this angle SAB plus SAD, these two angles ka sum gives us angle A. So from this half, if I divide this by, now this and this, they both are congruent. See, because this is the bisector. I have not mentioned it, but this question says that this AR is the bisector. So can we say that angle SAD is congruent to SAB? From these two, if they are congruent, can I say, instead of SAB, can I say SAD plus SAD equal to angle A? Yes or no? So this will give us 2 SAD equal to angle A. Therefore, SAD is equal to half of angle A. So from this, can I substitute half of angle A as SAD? So this will be angle SAD, correct? Same way, can I substitute angle D, okay, which is this angle, this full, okay, this full angle is D. So that half of D, can I substitute it as SDA? Similarly, okay, same this way itself we can do, equal to half of 180 is 90. So from this, what do we understand? See, SAD, okay, and SDA, their sum is equal to 90 degree. So if we consider triangle ASD, in triangle ASD, okay, angle ASD plus angle SAD plus angle SDA. Yes or no? If this is a triangle, the sum of the angles is 180 degree. So we can write the reason. sum of angles of triangle. Now from this, can we say SAD plus SDA? So these two is equal to 90. So we can say ASD plus 90 equal to 180 degree. Therefore, angle ASD is equal to 180 minus 90, which is equal to 90 degree. So here, this angle we have got as 90 degree. Okay. So after this, see, what we are trying to do is trying to prove that each of the angles are 90 degree. If we are able to prove, then this will become a rectangle. Okay. So if this is 90 degree, ASD, this is forming what? Vertically opposite angle. So angle ASD is congruent to PSR. Yes or no? Isn't it forming like this? This angle and this angle. So this and this. If this is 90, this will also be 90. Vertically opposite angle. Okay, we have discussed this many times. So we can say vertically opposite angle. Yes or no? I hope you are understanding. Therefore, ASD is 90. Therefore, PSR is equal to 90 degree. Okay, so this is one thing. Okay, so we got PSR equal to 90 degree. So from this triangle we got this as 90 degree. Now from this, okay, from this triangle we can prove that PQR is also 90 degree. Okay, so we can write here similarly PQR is also 90 degree. Okay, this can also be proved 90 degree, and this can also be proved to be 90 degree. Okay, so once you do it, you will be able to understand. So we can write similarly, we can say SPQ is 90 degree and SRQ is also 90 degree. So if you are able to prove PSR 90, if one of the angle is 90 degree, then all the other angles will also be 90 degree. That is understood. But then we can consider each triangle and we can try to prove that all the other three are also 90 degree. Okay, so this is what we get similarly with the help of similarly. Therefore, if each and every angle is 90 degree, we can say that quadrilateral PQRS is a rectangle. Okay, so I hope you have understood this question. Okay, so this is it from my side. I hope you have understood the questions. We took some theorems, the statements of those theorems, and we solved questions based on them. Okay, so I hope you have understood this video. In the next video, we'll be taking this chapter further and we'll be discussing about other quadrilaterals, which are rhombus, rectangle, square. Okay, and we'll be solving questions based on them also. Okay, so if you have understood this video, make sure that you share it with your friends. Okay, thank you for watching.